All right, so what we're going to do today is look at implicit differentiation with trig functions. The rules are all identical to what we did yesterday. So we're still going to take the product rule, the chain rule, everything the same, but now we might have the product rule with a trig function. So what we're going to look at to start is we have x cubed y. So we need to identify that that's two variables being multiplied together, so we have the product rule. And then we also have y cosine x. So we need a product rule in there as well, because we have a variable y being multiplied by cosine x. And then that's equal to our lovely 10, which we like because that will zero out. So let's product rule the starting one. It's the first times derivative of the second. So exactly, dy dx. So that's nice. Plus the second, which is y, times derivative of the first. Okay. Plus, and now we're going to look at the second part. So it's, once again, first times plus and then that all equals to 0. Yep.
So we just take the derivative of that side too. Is that okay?
So dx's become 1. And then again, our goal is keep dy dx on the left and move everything else to the right. So we're going to keep x cubed dy dx. Yep. And then subtract the rest away. So minus 3x squared y. And then since this is a negative sign, when we move it to the other side, it become a positive y sine x. Exactly. Yep. GCF. Precisely.
I mean, it's not bad. No. I got you the stamp for a while. It just takes a little bit to figure out.
It does. And it actually takes doing the problems, I feel like, in the homework on your own to understand it more clearly than when I was standing up here and trying to write it and say it, and it's like, but now, like, it's like, oh,
That's where I get stuck a lot. Like, I can do it when we're together in class, and then I go do it by myself, and I'm like, wait, am I supposed to do this? No.
I understand the homework for the most part normally, but then there's a couple problems I'm just thinking, what do I do?
It's starting a problem sometimes that you look at and you go,
Yeah.
and I always say, like, if you can't see it immediately, like, go do something, do a different problem, and, like, come back to it, because I even like, read a problem sometimes, and I go, wait, I get it. They're just setting you up to be a little, you know.
So could you go any farther than that?
No. I mean, there's really no, you could take out a GCF of y here, but it doesn't really benefit you. Okay, number 2 is a little trickier because now we have the chain rule with implicit. So if you think about sine x plus y, the chain rule says derive the outside. So the derivative of sine is, yep. So it would be that cosine of x plus y. But then the chain rule says,
you multiply by the inside, in this case, dx over dx plus dy over dy.
exactly. No, but I knew what you meant, right? So you have to make sure you multiply by the derivative of that inside. So it's like 1 dx dx plus 1 dy dx. And the only reason I'm putting the 1 there is just so we don't lose it later. But yeah, you have to make sure you multiply by that inside chain rule derivative. Then over here, we have another. Yep. So it's first times derivative of second. Good. And that would be a dx dx plus the second times derivative of first. This is, I think, where we honestly make the most mistakes. This cosine xy, it gets distributed to both of those. Because we tend to just like not know what to do with it. So it becomes cosine x plus y, and this is really like a 1, plus cosine x plus y dy dx. And then that equals your y squared secant squared x plus 2y tan x dy dx. So now we have some manipulating and flipping to do. We got to get the 2y tan x over here and the cosine xy over there. So we have cosine x plus y minus 2y tan x, all being multiplied by dy dx, equaling y squared secant squared x minus cosine x plus y. Don't try to cross out that cosine x plus y in the numerator and denominator. Remember, they're being added or subtracted to something else. So you can't just cancel them. And honestly, manipulating these, because again, remember our angle rule says cosine x plus y could really get rewritten as cosines and sines, but there's not going to be a benefit to that either because we have the secant squared and a tangent. So that's our answer.
What would that look like when they break it up? Because we never really talked about that last year, and I never really
Oh, this one? So if it's cosine, it's different than sine. The sine one becomes sine and cosines together. The cosine one would become cosine x, cosine y, minus sine x, sine y.
I don't even remember that.
Yeah, we didn't talk about it last year,
So maybe we'll do like some trig. I have a trig review handout. So maybe we'll do that on Friday too.
because I know they were
Like
the
it's all
that we got over the summer, but like because we didn't really use them a lot, I don't really remember them.
like the identities. All right, maybe we'll do like a little bit of trig review on identities and stuff.
Because that's what I was doing on the test too. Like I didn't remember them because like we didn't use them a lot. And I was like, this is not good.
I don't remember using that at all.
So I don't even know. If
The only one on the test was the secant squared tangent squared one. It turned to a 1. There was a time on the test it was like secant squared x minus tangent squared x
I
was
think
1.
I tried to get
Oh, I remember those.
cosine and got there eventually. So
Like I remember
okay.
sine squared plus cosine squared equals 1. But I don't remember all of them though. Isn't it like tan is with secant and cosecant is with?
Yeah, tan is with secant. And cosecant. It's just like our derivatives. Secant and tan are grouped together, so they're an identity, and cosecant and cotan are grouped together. Yep.
I really only remember last year using the cosine squared plus sine squared. That's all.
Equals 1.
Yeah.
Maybe we'll do a day of trig. I love trig identities. I love trig trig, like showing one side's equal to
I
another.
love that. Just for trying to work that out for like the whole class period on the board, and we would just go and get done with so many. Do you remember that?
Yeah, I remember that.
And we just did so many, and everyone was like, "How do you guys do that?" We were like, "I don't know. Like it's only with just four that I can do it." We worked so well.
I just remember doing it on those papers. Like, I could get some of these other ones. I remember just kept asking me, where did you get that from?
Yeah.
Where did you get that from?
Oh, so we would keep that. Oh, so it's just product rule with those two.
Yep, it's a product rule, and I would group the 5 with the sign,
Okay.
and then keep the cosine by itself. So it'd be first, which is 5 sine x, times derivative of the second. So the derivative of cosine would be negative sine. Exactly, it'd be negative sine y, dy dx, plus the second times derivative of first. So again, now it's the idea of 5 sine x is 5 cosine x. Yep. And really, you could do a product rule with the 5 sine x, but we know that since it's just a 5, it's going to zero out. Exactly. Good. Which is really going to become a 1. Yep. So you can't combine the sine x and the sine y because they're different variables.
Yeah, no, I don't.
Negative 5 sine x sine y.
Yep. dy dx
Yeah,
plus 5 cosine x cosine y equals 1. So you're going to subtract the 5 cosine x cosine y over, leaving negative 5 sine x sine y dy dx equals 1 minus 5 cosine x cosine y. Now, if you wanted to clean this up, you could think about the fact that your denominator could split with both numerators and denominators. And what do you know about 1 over sine? It becomes what? Yep. So you could say negative 1/5 cosecant x cosecant y. Careful. So it would actually become plus, because they'd both be negative, and the 5s would actually cancel. And then exactly, what's cosine over sine? So it'd be plus cotan x, cotan y.
We can just leave it like that though, right?
Yeah, and honestly, I would probably turn it into this in case they said find a second derivative.
Okay.
So by doing this, if you had to derive this again, or if you had to, maybe evaluate it at a point, sometimes getting rid of a fraction is helpful. Come on, Jason. I'm not kidding. You're fine. Okay, and last but not least, xy squared equals secant xy. So I purposely picked this one because the product rule inside the trig function, because it's different than when you're adding them inside the trig function. Exactly. So it's first, which is x, through the second, plus second derivative of first equals a product and a chain rule, right? So derivative of the outside is derivative of secant. So secant becomes, got it. Yep, you're right. So it'd be secant xy tan xy times the derivative inside, which is a product rule.
Oh, yeah.
So it's first, which is x, derivative of second, plus the second, which is y, and derivative of the first, which is dx dx. Dx dx is 1, dx dx is 1. And then now we're going to like distribute, clean it up. So you have 2xy dy dx plus y squared equals, and this is where I would distribute it again.
Oh,
X secant xy tan xy
oh, cool. Okay.
dy dx plus y secant xy tan xy. The only reason I pull the x and the y's out in front is because by bringing them out in front, you don't necessarily mix them into the angles.
Yeah.
Sometimes when you put them at the end, or if you don't put these in parentheses, we get like a little bit confused.
Yeah.
So now we have 2xy minus x secant xy tan xy dy dx equals y secant xy tan xy minus y squared. Divide and conquer. Dy dx equals y secant xy tan xy minus y squared all over 2xy minus x secant xy tan xy. You could do some manipulating, but it wouldn't really like help us. Because if you think about it, we could substitute. We know secant xy is really xy squared. So you could get rid of the secant xy's by subbing that in. And maybe you're going to cancel like a few x's and y's because of that, because you could GCF out a y from them both. But beyond being able to cancel some things out, plugging it in doesn't help you a whole heck of a lot. But remember that it is an option. Because just like yesterday, we had the x to the fourth plus y to the fourth equals 16. Well, that did help. That did simplify. So those are the things you're looking for when you're doing these problems is, can I back substitute something in and make this simpler? So are you plugging it in now just to see what it does?
Yeah, it's slightly smaller.
I mean, it is, right? Like, so if you think about it, this y times secant xy would be like xy cubed tan xy minus y squared all over 2xy minus x squared y squared tan xy. And then, like I said, you could cancel out. Look, they all have a y now. So we could take away a y. Okay. Let me confirm those values. I want to make sure we didn't do anything yesterday. But I know we didn't do the 5 to 8 for sure. Because I remember being like, skip 5 to 8. So you did 1 and 4. So 5 to 8 are good. And then we did, what, 17 to 22? And 9 and 11. So do I have 13 to 16 on there? That's okay. There's only one trig one in there. So 23 to 30. They're all good. And 45. Hmm. 45 is not good.
Should we do 45 together?
Yeah, maybe we'll do. I'm gonna switch